good morning to all our listeners. I'm going to kick away straight into the session. My aim today is to introduce you to an interesting subject of plumbing in Dolomite, and I truly hope that I can paint a picture as to the importance of good plumbing practices and those risks associated with poor infrastructure within these kind of areas. So I think to try and start painting that picture, what I'd like to do is to try and just touch on what is dolomite. So dolomite is a rock composed of the mineral dolomite. It's relatively impervious, so it's not penetrable. It's insoluble in pure water, so it doesn't dissolve, and it possesses many fractures, joints, faults, which act as passages for water ingress. So it's also referred to sometimes, you'll hear people say it's a carbonate rock. So when someone says carbonate rock, think about things such as dolomite and limestone. It falls into that type of category. So let's have a look. The definition of dolomite, and I'm going to just read that section to you. It's basically land that's underlain by dolomite or limestone rock directly or at a very shallow depth, typically less than 60 meters in areas underlain by limestone, and then 60 meters in areas underlain by dolomite, where no dewatering has taken place. Dewatering, obviously drawing off of water from the underground tables, and that the local authority has jurisdiction of that area and is monitoring and controlling that groundwater level. And then also it makes mention to 100 meters, and that's where it's underlined by dolomite, where dewatering has taken place. So there's been a lot of dewatering that has taken place, but unfortunately the local authority has no jurisdiction or control over that groundwater levels. Dolomite itself, areas are categorized, and this is the way I try and explain to myself. It's categorized by guys that do special reports, geotechnologists, and it's really covered within certain levels of risk. So as you can see on the bottom left-hand corner, it's dolomite areas are given a designation. So if it's a D1 area, there's no precautionary measures required. D2 and D3, that's where, for example, SANS 1936 will provide guidance. It'll tell you this is what you can do in this area, this is what you can't do in this area. And then obviously D4, which is on the high end of the risk, and there's additional and specific precautionary measures that are required when putting in that type of infrastructure. I'll talk about infrastructure a little bit later and give you also a little bit of a definition on that. Picture on the right-hand side, it's found in SANS 1936, and it basically shows you a distribution of carbonate rocks in South Africa. As I mentioned, it may not affect you. You can see the legend in red, it says carbonate rocks, and where you see it on the map that's extensively where this carbonate or dolomitic rock is found. So as I started, it may affect you, it may not affect you, but if you're ever going to work in an area like this, just maybe bear in mind or maybe make just a mental note that you may be working in an area that has these kind of designations. So as I mentioned, there is a standard that sets the requirements for development of such dolomite land. And this risk, or these specific requirements need to be done by a geologist. There's a lot of high professionals that get involved. And basically what the point I'm trying to make is that it's covered in 4 sections or 4 parts. The first part is where they then get that classification. A competent person will look and conduct those geotechnical site investigations, establish data, and then basically get to those categorizations, D1, D2, 3, and 4. Part 2 covers basically the construction, what type of construction, what type of buildings can be on this land, and also the infrastructure. Part 3 basically covers the design, construction, buildings, and the infrastructure, and that's the one that we're going to be spending a little bit of time on. I'm going to try and do this over 2 sessions, which I will explain a little bit later. It is quite an extensive topic. And part 4 basically is the risk management. So once they've got that information, it's an ongoing process. It doesn't just get forgotten about. You'll find that the local authorities in whose jurisdiction that these developments or future developments would fall must implement and maintain a dolomite risk management strategy in accordance with the principles and requirements of SANS 1936, and it's obviously part 4 that it's making mention to. So obviously, when they design and when they put this together, they're obviously always taking into account this is a society, building types, what type of buildings can be put up there, the density of the buildings, how many buildings are going to be put up there. So with that being said, I just want to point out that I've made infrastructure in red, and infrastructure actually covers a huge um, uh, topic. For example, it would cover the runways, the roads within a development, liquid retaining structures, stormwater systems. Guys, think about things like power lines, including maybe even sewers, reservoirs, swimming pools, retention ponds, stormwater management, dams, reservoirs. It covers a lot. And that's why I've just highlighted it, just to say it's huge. When you see the word infrastructure, there's a lot that goes into a development. So I live in an area that's not classified as Dolomite. A few kilometers away from me, it's another municipality, and they have dolomitic land. And I just wanted to say to you that, if I'm working in that kind of area, or if, let's say, if I've got a building or a house that I want to build, and I needed to get some more information as to what I can and can't do, I really encourage you to engage with your local council on if the area does have any dolomite or special requests, and you'll find that sometimes that when you engage with them, they have geotechnical reports, there's investigations that they may be able to share with you, records. They might even be able to say, well, in that property, you need this is the classification as a D1, D2, D3. I know that Midville themselves have sent me a nice brochure of the area, and they also cover the topic of dolomite and what to consider and what are the good practices that you need to do, and what are those preventative measures, which is very nice and useful. So just as an example, within at the bottom section, you'll see that it says there that, so I inquired about an area, and then they said that Daleside, which falls into their precinct, is then stated as a dolomitic area, and all development applications in the area will be subject to a detailed geotechnical investigation. So guys, engage with them, find out, see if there's any special requirements that they need, especially if you're putting plumbing or doing plumbing in the specific area. It's really, that's where I would urge you to be your first point of call, just to see if you're in an area where these risks could be clearly associated with dolomitic land. So as mentioned, we're going to be focusing on part 3, which is the design construction of buildings, structures, and infrastructures. And I just want to read the scope to you so that we have a clear understanding of how important the infrastructure is. So within SANS 1936, part 3, it establishes, like I said, the requirements for the design construction of permanent, and it also includes temporary buildings. So if you're putting up a temporary structure, some toilets in that, while you're building them, let's say, for example, the person's building a commercial property or some buildings, it even covers that temporary building, structures and infrastructures, including wet and dry engineering services on dolomitic land, requiring precautionary measures to support the sustainable development. It also applies to upgrading and maintenance of existing developments. So guys, when I see the word upgrading, a couple of things come to mind. So you might have a client that's bought a piece of plot, or has a plot or a farm, and now you start subdividing that farm. Suddenly the infrastructure becomes more, the density becomes more infrastructure, more alterations, and so you could be adding to those kind of risks. So it covers maintenance, existing, and temporary buildings is the point that I just want to raise with you. This part of SANS also establishes or tells us exactly what those requirements are for designations D2 and D3 dolomitic areas, and it also covers the development of sites on D4, which is at the high end of the risk factor. There's obviously additional specific precautions that need to be considered on a D4 category. So, interesting stats. South Africa research shows that 96% of sinkholes and subsidence that have occurred to date were man-induced, guys. This is generated by the ingress of water from leaking water-bearing infrastructure, poor stormwater management, and it is a very, very high number. I just want to show you some of the photos there on the left-hand side, whatever that was, when it was originally put in. I can tell you now it wasn't put in with that kind of risk. There's obviously that water has leaked with water, whatever it was transporting has leaked in that pipe system, and that is the result. And look at the danger on that picture on the left. One's in the middle. I think the one at the bottom middle is in Pretoria somewhere, where the sinkhole was the size of could swallow a car. And it's just as a result of poor infrastructure. The joints not properly sealed, water started to eroded the erosion caused some areas of dolomitic to dissolve, and then it just starts caving in and it causes a huge risk. Picture on the right-hand side is more to do with natural sinkholes forming. So if you look on the top of that picture, you'll see there's like a little tree. That's not, obviously not in the not the tree that's dead, that's lying in the doline or the sinkhole, but the topography is basically so the ingress of water has been running down over a couple of years or a couple of tens of years, and obviously it's run to a point where it then ponds up and then it just leaches into the surface, a subsurface, and into the soil, and eventually with maybe a bit of dewatering or anything of those kind of things, it starts to then cave in. And as you can see, there's a little guy standing there, extremely dangerous. And you know what? You could be walking on a surface that's fine today, and tomorrow you got a hole the size of anything from 2 meters, 15 plus, and these do get categorized in size. So the way I try to understand this, because it's a huge subject, it covers 4 parts, was to try and do a bit of a drawing. So I hope you guys enjoy my drawing. I've got a little red dot in the middle of that where the arch and the cave is. On the left-hand side, just to touch on natural water, and the blue little lines that you're seeing on my drawing are those fractures and faults and zones that I've referred to earlier. And on the other side is the man-made triggers or the mechanisms, which I want to touch on now. So let's just first have a look. So normal natural waterfalls, it's pure falls, it's got to go into the little crevices, it eventually goes down, it lies in the water table, and it's natural. These things do occur. It's where man starts to play a part, or he plays a hand at changing things. So let's just have a look. So let's just start off with the house, and you see the CO2 happening. So as soon as you have pure rainwater, which now becomes, let's say, charged with CO2, or carbon dioxide, it passes through the atmosphere and obviously runs on the surface or on the soil and goes into the groundwater. Suddenly, that water is no longer pure. It now becomes slightly more acidic. And the only way to try and explain it to you is, and I put a little bottle of soda water on the left-hand side to say to you, so H2O charged with CO2, soda water. As soon as you start shaking it and you leave it for a while, you'll probably find that carbonated water becomes a little bit more acidic. So people always sometimes might say, this tastes a little bit salty or sour. And I think that's the way I can only try and explain to you that you've made the pure water slightly more acidic. That then runs through those faults and fractures and zones, and it starts to, and the word I'm looking for, it starts to dissolve the dolomite and the limestone. So that's on the one side. If you look at on the man's intervention side, let's just start off by looking at one little house. That little house needs infrastructure. It needs, as we said, wet services, and it needs dry services. But the wet services, we're going to focus on here. So it needs maybe some water, main lines, water coming in. It needs the reticulation around the house itself. It drains, so it brings in some good stuff, take out the bad stuff. But if the plumbing is done not correctly, and you find that water or that stormwater starts leaching into this ground surface, it'll also follow those fissures and faults and cracks. And now suddenly, and think about soil itself, urine, it's got a higher acidity, and suddenly that adds to or starts slowly dissolving the rock, and that brings that instability and safety. Other factors may be that, for example, the person has put up a man-made dam. So now he starts eroding the first couple of layers of sand and clay. And as we saw, it's very low, 60 meters, as we said on the first or second slide. And what happens is, it now suddenly the person is eroded. It's a man-made dam, and it's now it weighs a lot. So first of all, it causes the pressure on the surface, on the subsurface. And obviously that water in that dam stands exposed, and it will also then start leaching and then start following these fractures and dolines, speeding up the process of dissolving the dolomite and clay. Dolomite and limestone. Other factors that add to this is you might find that there's a lot of borehole and draw off of the water table. So if I can just draw your eyes back to the arch next to the little house. So when the water table was nice and high, maybe when there was no man-made infrastructures, that arch may have been supported, and water is impressible. So it may have been supported with water below it. And as they've drawn off, or as man has drawn off water from the tables below, suddenly, you're left with a cavity that's not supported, doesn't have any type of extra support. And then you get those things like a rock fall, an archway that falls in, and you're going to have this doline or this cavities that are forming. Think about other things that may also affect. I mean, there's so many that I can think of. I'm thinking of things like French drains. Just normal supply lines. Think about maybe agricultural fertilizers, anything that could enter that fracture or those dolomite crack lines that would add up and speed up that process of erosion, in other words, or dissolving of that dolomite. Guys, I hope that paints a picture. That's the way I try to understand these primary trigger mechanisms. I hope it makes sense to you guys as well as what I'm trying to explain. That is, the more the man's activity happens, the more draw off, the more open, the more surface, can I say, almost the more surface interaction and the more surface, for example, digging of drains and excavation, the higher the rate of, or the potential of these dolines falling, especially if you're in an area that has a high categorization, D2 and D3. Saying that, let's have a look at a few things. For example, where you're in a D2 or D3 area, so bulk pipelines, there is some guidance that's given. And I can just read this. It says, where reasonably practicable, bulk pipelines shall be located at least the following distances from the nearest residential, institutional, or commercial property boundary. So not from the actual building wall, from the boundary of the property, excluding buildings associated with the pipeline. So D2, 10 meters, D3, 15 meters. And guys, I've put this in just to raise awareness that it's so serious, and the risks associated to this, that if any of the requirements of this part of the standard are not reasonably practicable, so they're not cannot be implemented. Alternatively, there's problems, or we can't get to the 10 meters or 15 meters. There needs to be a rational assessment that needs to be done by a competent person, geoprofessional or engineer, where it's appropriate. And then they need to go and do a risk management. They need to go and do some checks, studies, and tests. They need to do some drawings. They need to indicate the non-compliances. It's a very, very involved process. And obviously, remember, at the end of the day, it goes about the safety of people that are living in these kind of dolomitic areas. Supporting documents need to also be attached and also be signed by a competent person providing reasons for this non-compliance. So, guys, huge risk management processes are in place. It gets governed by, as I said, 1936. Dams and reservoirs, liquid retaining structures. So that liquid retaining structure could be a stormwater retention facility, ponds. I always struggle with this word. Please forgive me if I got it wrong. Attenuation ponds. Sewer retaining ponds shall be reasonably practically located 20 meters. And once again, the importance is that it's away from a building, unless it's a facility, for example, water treatment plant or a sewage plant that can be closer. So excavations for infrastructure. Guys, I haven't covered everything. It is a very extensive document, but I want to just highlight a few things to you. So the length of time of excavations are left open. Yes.
Just a reminder, we are at the 20-minute mark at the moment.
Already. Okay. Yes. So let me go a little bit faster. So guys, shall be kept to a minimum to reduce the likelihood of subsidence and sinkholes. The length of the trenches mustn't be long lengths. They should be kept short and shall be limited to achieve, that it's not open for long times. Regarding backfilling of the trenches, it should take place as soon as possible. And obviously, the other thing on that is that obviously backfilling needs to be done in accordance with specific requirements from a competent person, engineer. They may say, listen, we want you to fill it like this and like that and with that substrate. and that's always directed by a competent person. Stormwater drainage, guys, stormwater drainage, it says it shall discharge into the natural water course unless the land upon which it is discharging onto is classified as non-dolomitic land or non-dolomite land, and dolomite land that is categorized as a D1. Any stormwater drainage shall be such that no surface water must pond in the natural water course, other than in a natural water course, or in appropriately designed attenuation pond. That retention pond or attenuation ponds on dolomite land other than D1 shall be limited to an amount of 6 hours. So it can't be more than 6 hours. Stormwater retention and attenuation ponds shall be rendered impervious, with meaning obviously that it's mustn't leak or leach as such. The means of control and disposal of stormwater around buildings must obviously be in accordance with SANS 10400R, which covers stormwater, and it'll always be running away from the buildings in a control. So obviously you don't want stormwater backing up onto the house, but rather moving away from the house. But channels, I think the important part that channels and canals need to be lined. They need to be sealed properly and they need to be watertight. Any diversion of trenches shall be avoided as far as possible. If obviously water needs to be diverted away from the building, which we've just touched on, stormwater drainage shall be incorporate measures to ensure water tightness. So there should be 0 leaks. These including the sealing of joints. So guys, just follow the instructions of whoever is the competent person. There may be very specific requirements as to how they want those drainage systems sealed or closed or lined. Okay, so stormwater drainage conveyance system shall be designed, I just want to stress this, to gradients which are self-cleansing. Such system shall have an internal diameter equal to or greater than 300 millimeters. I think the reason for self-cleansing is that I don't want a lot of maintenance happening around these stormwater drainage systems. I'm going to just then move to the next one because I want to just spend a little bit of time on this one. I know we're running out of time. It talks to sanitation systems in dolomite land, which is classified as a D2 and D4. Guys, what's very important that in these areas, you shall not have an evapotranspirative beds, or in other words, soakaways or French drains, as the picture on the right-hand shows you. I've put a big cross over it. Conservancy tanks need to be used where there's no municipal waterborne sewage connections, where they're not available. In order so that when the sewage goes into it, it needs to be collected by one of those suck-up truckies, and they take it away to a place where they can dispose of it in a proper way, in a manner. But guys, if an alternative is available, I just want to touch on pit toilets. In accordance with the requirements of 10400Q, it may be utilized, but only on sites that are designated as D1 and D2, provided, and this is an important part, that they're designed and implementation is approved by both competent person, engineer or geoprofessional, as well as the local authority. Just make sure that both are covered and that you have approval from both. Toilets, toilets that can be obviously constructed to prevent stormwater gaining access into it. Makes perfect sense. You don't want to have sewage mixing with stormwater. You're going to fill it up, it'll just leach into the soil. It'll add to that dissolving of the dolomitic land. It is required that you remove pit toilets. As you see, it says advisable that that they are moved, and when they are redundant, that they're filled up, allowed to be dried, backfilled and compacted with suitable material that's obviously more dense than or permeable than the surrounding natural material. So guys, pit toilets, just to end off with, shall not be provided on sites D3, and I don't even mention but D3 and D4. So no pit toilets there. Sanitation, as I said, the only other point that you need to remember is that you can't have ingress of water happening into those pit toilets. Thank you for listening to me, and have a beautiful day, everyone.